Hello children, welcome to the another session of IPNCS grade 11 by your sir Vinay Tiwari. Today we learn about the processing. What is processing? Understand the central processing unit. Definition of CPU is central processing unit is referred as CPU, defined to be the part of the computer, the bulk of data processing operation. In simple word, CPU is hardware component of the computer that does most of the work in executing a program. The CPU is made up of three major parts, which is register set, arithmetic logic unit, control unit. Children, so far you have learned that the CPU is brain of computer. It controls the operations of computer, blah blah, in your lower classes. Now here you will learn something advanced about CPU. Uh, Let us understand the working of CPU with the help of this diagram. Register set. Register set is store intermediate data used during the execution of the instruction. Arithmetic logic unit, which is also known as ALU, performs the required micro operations for executing the instructions. In simple word, ALU is the unit that performs the calculation, sorting and comparison operation. And control unit supervises all activities, the transfer of information among the register, and instruct the ALU as to which operation to perform. In other words, control the operation in CPU. And there is another unit associated with CPU, that is clock unit. The clock unit controls the speed of the computer. Types of instruction cycle. You must have read about the program, the definition of program, that is, the program is set of instructions. Now the control unit of a computer is designed to go through an instruction cycle that is divided into three major phases. First is fetch the instruction from the memory, second is decode the instruction, and third is execute the instruction. So after third step, again the computer will go for the first step. So this is how the instructions used to work in the computer. We can more understand this with the help of this flow diagram. Control unit controls memory, ALU, IO unit. IO unit are interconnected with memory and ALU. Even memory and ALU is interconnected as far as data is concerned. So data used to transfer from these devices from each other. History of ALU. Mathematician John von Neumann proposed the ALU concept in 1945 in a report on the foundation for a new computer called the ADVEC. And the typical symmetric symbol of ALU is like this. ALU is the information and you will get a result with the F instructions, and D is the output status. ALU operations are of two types: fixed point operations and floating point operations. Fixed point or integer ALU operations are add with carry, and subtract, multiply, subtract with borrow, divide, unsigned divide, or XOR, NOT, L shift or R shift. And floating point ALU operations are FAdd, FSub, FMUL, that is multiply, FDIV, that is division. And there are three types of functions: arithmetic operations, bitwise logical operations, bit shift operations. You must have read about different type of number systems. So ALU for each of these numeric systems had different design, and that influenced the current preference for two's complement, as this is representation that makes it easier for the ALU to calculate addition and subtraction. Now we talk of memory, and before we talk of memory, we should know the unit of memory. The smallest unit of memory is bit, then nibble, then byte, then kilobyte, megabyte, and 1024 megabyte creates 1 gigabyte, and then terabyte. Memory unit. Memory unit is a device to which binary information is transferred for storage and from which information is retrieved when needed for processing. A memory unit stores binary information in groups of bits called words. The internal structure of memory unit is specified by the number of words it contains and the number of bits in each word. The memory unit is an essential component of any digital computer science. It is needed for storing programs and data. Not all accumulated information is needed by CPU at the time. Therefore, it is more economical to use low-cost storage devices to serve as a backup for storing the information that is not currently used by CPU. The crux of this write-up is this, that the CPU interact with the primary memory, and from the primary memory it used to interact with the RAM. The purpose of the storage unit is the computer is to store the data entered before processing and also to store the result after processing. Physical device used to store program or data or temporary or permanent basis. For use in a computer, memory data is stored in the form of chips. Storage is done by data stored in tapes, disk, or your USB drive and CD, DVD. Storage unit, primary storage unit, and secondary storage unit. So, CPU interact with the RAM. Then why we need a hard disk? We need hard disk to store the program before or after the result, because the program which is processed, which is currently in the RAM, will not be there for longer, so you have to save it in hard disk. Primary storage device or random access memory. The term random access memory means that any word in the memory may be accessed without having to go through all the other words to get to it. It can read and write. Memory consists of integrated circuits either on motherboard or a small circuit board attached to motherboard. Memory enhanced easily by adding memory chip. It is volatile from the memory and it looks like this. RAM. The write input causes binary data to be transferred into memory, and read input causes binary data to be transferred out of memory. RAM can be classified into two types, that is DRAM and SRAM. And SRAM is more advanced than DRAM and it takes less time, and DRAM takes longer time to read and write from the location. Now we talk for ROM, read-only memory. ROM is built-in computer memory containing data that normally can only be read, not written to. ROM memory is preset memory. ROM is one in which information are stored permanently. The access time for memory is very fast. ROM is very expensive to design and manufacture. ROM stands for read-only memory, means output data bits corresponding to the address bit set at the input. The bits are used by some processor or device or circuit for further operations. Data bits of different addresses is stored at ROM, and all bits remain stored in memory even after a power interruption or power switch off. ROM is randomly accessed. An equal time interval is taken for a read of data bits from each address. Address bits can be set randomly by an external circuit. ROM has an address decoder, that is an to N decoder within it. Let me explain you in a simple way. Children, you must have started the PC, and when you start the PC, you must have seen this um, type of window appearing, right, where the black window is there, only some white letters information are coming. This work is done by rom initialize all the data. Rom initialize all the setup of the CPU, all the peripheral. It checks whether keyboard is working, mouse is working, hard disk or RAM extra is working. After getting clearance from every way, it start Windows. And when you receive this message starting Windows, this is the time when RAM activates and it is fetching or retrieving information from hard disk with regard to start of Windows. ROM is used for storing program that is permanently resident in computer and for tables of constants that do not change in value once the production of the computer is completed. ROM is non-volatile memory. It has continuous source of power and do not need periodically refreshed. Under ROM comes PROM, EPROM, EEPROM, and EAPROM. Secondary storage devices. In this section of memory is also referred to as a backup storage. The storage capacity of primary storage is not sufficient to store the large volume, so secondary storage is there. Secondary storage, also known as external memory or auxiliary storage, not directly accessible by CPU. Secondary storage devices are hard disk, floppy disk, which is not in use now, compact disc, CD or DVD, tape drives, cassettes, and DLT, digital linear tapes, DAT, digital audio tapes, micro vault USB storage device, your media, uh, your USB drive. There are two general types of hard disk. Hard disk drives, which use one or more rotating disks and rely on magnetic storage, and solid state drives SSD, which have no moving mechanical part but use flash memory like the kind of found in USB flash drive. Flash memory. Flash memory is a special form of EEPROM, that is electronically erasable programmable read-only memory, which uses normal PC voltages for ensure and reprogramming. Flash memory is often used to hold control code such as basic input output system, which is also known as BIOS, in a personal computer. When BIOS needs to be changed or rewritten, the flash memory can be written to in block rather than byte sizes, making it easy to update. Example of a flash memory device applications are storing messages in mobile phone, storing photographs and digital camera. So you must be using these memories in your day-to-day life. So conclusion of this lecture is this, that we have learned today about the CPU, parts of CPU, that is register set ALU and clock unit. Then we learned about the memory unit, and in memory unit, primary memory and secondary memory. In primary memory we have learned about RAM and ROM, and in secondary memory we have learned about the various storage system of computer. Now before I conclude, let me ask you to note down these terminologies: RISC, STACK, stack, RPN, CISC, interrupts, and learn about these terminologies. Although these terminologies are not included in your course, but for having a deeper knowledge about the functioning of computer, you should learn it. And in case you want to ask anything, please make call at 977-240-3161 or mail at vinayblue@gmail.com. Thank you. Take good care.